Hi.
Hi.
What you going to tell me today?
Naming cycloalkanes.
Okay.
Okay, so we can have a carbon chain like this. And on the notation like this. So let's say we need to name it. So first the thing we look at is how many carbons. Well, if we count it, 1, 2, 3, 4, 5, 6. 6 carbons. So the name of this is cyclo, coming from the fact that it's a ring instead of an open chain, and hex, coming from that it is a hex. 6 means hex. The table is like this. There. So, and lastly, we've got ane because it's an alkane. So, what if we had some substitutes? So, if we had the same thing we had before, this time with a substitute group, then what would the name be? It would be the longest carbon chain would be the same as the cyclohexane, but there's a functional group added to it. The functional group. The first thing we look at when we're naming the substitutes is how many carbons does a substitute have? We're not counting this one because that's a carbon which the cyclohexane has.
Okay.
So that one, that we've only got one here. So it's called meth. The meth. So it is, and so it is methyl. The eel shows that it's an alkyl, a substituent. Now, this is an example with one substituent. But what if we had more than one substituent? We would do something like this. Let's say we had the same cyclohexane ring, but this time we have got a substitute group here and here. This would be, well, there's still methyl groups again. So it's still the methyl cyclohexane, but now it's got another methyl group. So here, if we just named it dimethyl cyclohexane, di meaning two methyls, that would not be able to be distinguished from something like this. Here, this one is 1, 2, 3 carbons away from this one. I mean 2, while this one is 3. So, how do we number these? We need to number them. So, we can start at any carbon because this is just 2 and this is at a cyclic compound. So, we will number them starting at one of the carbons. 1, 2, 3. There are 1 and 3. Here, we can start at any of the carbons, but we can do like this. There. So, when we're numbering them, we have 1, 3, dimethyl, and then our cyclohexane in the after we write the dimethyl, and second this would be instead 1, 4 dimethyl, cyclohexane. We can have more than 2 substituents too. If we had the same ring as before, like this, but this time had one here, and had one here. How would we name it? So, well, we could number starting from any of these carbons, but which one would be the real one?
The first one?
If we choose from any of these, we need to choose which one we should start counting from. And we can also count from any way.
Okay.
So we need to look at all of those different possibilities and see which one gives the smallest amount of numbers. The smallest numbers.
So it starts from the one below.
Let's have a look. Obviously, we might want to start from here. This carbon, because here we give 1, 2, 4. If we start from this one, we give 1, 2, 3, 4. 1, 3, 4. 1, 3, 4. So we need to number starting from this carbon. So let's number it down. 1, 2, 3, 4. That's how we're gonna number it. So now that we've got these numberings, we need to find out what the complete name is. So we are going to write down all of the positions just like before, the dash, and then we're gonna have, last time we had D. So this time we're gonna have try, because try means 3. Trimethyl, and obviously cyclohexane. The full name is then 1,2,4-trimethyl cyclohexane. That's it for today. Goodbye. Thank you.